Hello friends, this is Shachi. Welcome to my channel Crack Chemistry. Today's topic, quick revision series for board exams part 1 is for class 10th, in which I am going to tell you some very important tricks to learn and write the chemical reactions of the chapter Carbon and its compounds within minutes. Through this series, I'll discuss each and every point of the topic which is important for a board exam point of view, so that you can write a board exam confidently and you can score good marks. Before starting, I want to remind you to subscribe to my channel for getting information about further important uploads, and don't forget to like and share this video with your friends. So come with me and let's crack chemistry. So today's topic is chemical properties of carbon compounds, and I'll tell you tricks to learn chemical reactions within minutes. For remaining reactions, don't forget to watch the next part. First chemical reaction is combustion. Friends, you know that carbon in all its allotropic forms burn with air or an oxygen and gives carbon dioxide along with the release of heat and light. One more point. Not only carbon, but most of the carbon compounds, they undergo combustion and release a large amount of heat and light. This point I'll explain you by taking a few examples. So first example is of burning of carbon. Carbon is C. It undergoes combustion in the presence of air or oxygen and produces carbon dioxide along with heat and light. So this is a very simple reaction. Next reaction is the combustion of methane. Methane is CH4. So methane undergoes combustion when it is heated in the presence of air or oxygen. And products are carbon dioxide and water, along with the liberation of heat and light. Now I'll tell you the technique how to learn and write this reaction within minutes. You can see number of carbon atoms in the reactant side are 1 only. So, the number of molecules of CO2 produced will also be 1. So, always you have to remember one point, that the number of molecules of CO2 produced will be equal to number of carbon atoms in the reactant side. Now, we will discuss about water molecules. The number of water molecules produced will be half of the number of hydrogen atoms present in the reactant side. So we can see that in the reactant side we have 4 hydrogen atoms which are present in CH4 molecule. Number of water produced will be 2. So 2H2O. Finally, we have to balance oxygen. You can see that in the product side we have total 4 atoms of oxygen, 2 in CO2 and 2 in water. So in the reactant side also we must have 4 atoms of oxygen. So for writing 4 atoms of oxygen, we will write 2O2. I hope it is clear to you. Now we will take few more examples. Next example is of ethanol. Ethanol has the formula C2H5OH. As number of carbon atoms in reactant side are 2. So number of CO2 molecules produced will also be 2. Now we will see hydrogen atoms. In the reactant side, there are total 6 hydrogen atoms. 6 hydrogen atoms are present in ethanol molecule. So, water molecules produced will be half of 6. That is 3. So, 3 water molecules will be produced. Now, you have to balance oxygen atoms. For balancing oxygen atoms, we will count number of oxygen atoms in the product side. Our product side has 7 oxygen atoms. 4 oxygen atoms in CO2. And 3 in water. So, in the reactant side, there should be 7 oxygen atoms. So, if we look carefully the reactant side, 1 oxygen atom is already present there. So, we have to write 6 more oxygen atoms in the reactant side. So, for writing 6 more oxygen atoms, we will write 3O2. Next example is of C3H8. C3H8 is called as propane. Now, you can write the reaction very easily. Number of carbon atoms in propane molecule are 3. So 3 molecules of CO2 will be produced here. Now look at hydrogen atoms. In the reactant side, 8 hydrogen atoms are present. So number of water molecules produced will be half of 8, that will be equal to 4. Now finally you have to balance oxygen atoms. In the product side, we have total 10 oxygen atoms. 6 oxygen atoms in 3CO2 and 4 oxygen atoms in water molecules. So the reactant side should also have 10 oxygen atoms. For writing 10 oxygen atoms, we have to write 5 O2. I hope it is clear to you. Few more examples we will take. Next example is of butane. Butane is C4H10. So, as butane consists of 4 carbon atoms, so number of CO2 molecules produced will also be 4. Then look at hydrogen atoms. Number of hydrogen atoms in butane are 10. Number of water molecules produced will be half of 10. That will be equal to 5H2O. Finally, we have to balance oxygen atoms. For writing oxygen atoms, just count the number of oxygen atoms present in the product side. Our product side has total 13 oxygen atoms. 13 means 8 oxygen atoms in 4 CO2 and 5 oxygen atoms in 5 molecules of water. So our reactant side must also have 13 oxygen atoms. How can we write 13 oxygen atoms? For writing 13 oxygen atoms, we have to write 13 by 2 O2. The next compound written here is pentane. Pentane is C5H12. And you have to write the combustion reaction for pentane on your own with the help of trick which I told you just now. After discussing combustion reaction in detail, I want to tell you few important points regarding combustion. There are 2 types of hydrocarbons. A detailed description of these hydrocarbons I have already done in my previous videos. The link of these videos will be given in the description box. So there are 2 types of hydrocarbons. Saturated hydrocarbons. Saturated hydrocarbons are those which have only single bond. On combustion, they give a clean blue flame. Whereas unsaturated carbon compounds are those which have one or more than one double or triple bonds. So unsaturated hydrocarbons on combustion give a yellow flame with lots of black smoke. By this method, you can differentiate between saturated and unsaturated compounds also. But one more additional point I want to mention here. Although saturated hydrocarbons on combustion, they give a clean blue flame. But when saturated hydrocarbons are burnt in the limited supply of air, then they undergo incomplete combustion and burn with a sooty flame. Another important point regarding combustion. You all must have seen that the gas or kerosene stove which we are using at home has inlets for air. What is the purpose of these inlets? The purpose of these inlets is that sufficient oxygen can be provided for combustion so that the fuel burns with a clean blue flame. But sometimes you must have seen that bottoms of cooking vessels get blackened. What does it mean? It means that the air holes are blocked and fuel is undergoing incomplete combustion. Whenever a fuel undergoes incomplete combustion, less amount of heat is produced, which will cause the wastage of fuel. Another important point. Fuels such as coal and petroleum, they have some amount of nitrogen and sulfur in them. So whenever these fuels like coal and petroleum undergo combustion, the formation of oxides of sulfur and nitrogen takes place, which are major pollutants in the environment. Students, this is the board question which has been asked in the previous year exams. Another important point I would like to mention here. You all must have seen that fuels like candle or the LPG in the gas stove burns with a flame. But fuels like coal or charcoal, on burning, they simply glow red and they burn without flame. What is the reason for this? This is because flame is only produced when gaseous substances burn. If gaseous substances are not there, the flame will not be produced and the fuel will simply glow. So whenever wood or charcoal is ignited, if some volatile substances are present in them, they will vaporize and they will burn with flame in the beginning. But once all the volatile substances are consumed, then the fuel will simply glow red and will burn without flame. So we can conclude that a luminous flame is seen when the atoms of the gaseous substances are heated and they start to glow. I hope it is clear to you. Another important point, the incomplete combustion gives soot. What is soot? Soot is carbon only. You must have seen that the color of the candle flame is yellow. Why the color of the candle flame is yellow? The color of the candle flame is yellow due to incomplete combustion of the fuel, which releases soot particles. Soot particles are carbon. Another important point I would like to mention here, whenever metals or their compounds, they are heated in flame. This test is called as flame test. They produce a characteristic color, and this is a characteristic property of that element. For example, if you are heating a copper wire on a flame, it will produce bluish green color. In this slide, you can see the color produced by different metal salts when they undergo flame test. So lithium salts, they produce red color. Sodium salts produce yellow color. Potassium salts produce lilac color. Calcium, brick red color. Barium, green color. And finally, the copper produces bluish green color. Now, I will discuss formation of coal and petroleum. Coal and petroleum have been formed from biomass. This biomass was subjected to various biological and geological processes. How coal was formed? Coal is the remains of trees, ferns and other plants that lived millions of years ago. Due to earthquakes or volcanic eruptions, these were crushed into earth. Then they were pressed down by layers of earth and rock, and slowly they decayed into coal. So in this way, the formation of coal took place millions of years ago. Then what about petroleum? Oil and gas are the remains of millions of tiny plants and animals that lived in the sea. So when these aquatic animals and plants died, their bodies sank to the seabed and were covered by silt. So what is silt? Silt is sand or fine clay particles which were carried by running water and they were deposited as sediments. As these dead remains were subjected to very high pressure, under this very high pressure, bacteria attacked the dead remains and turned them into oil and gas. And in the meantime, the silt was slowly compressed into rock. The oil and gas which was produced by the bacterial decomposition of these aquatic animals and plants seeped into the porous parts of the rock, just like water trapped in a sponge. Coal and petroleum therefore are called as fossil fuels. Now I am going to discuss one NCERT question. The question is that why are carbon and its compounds used as fuels for most applications? Friends, in the beginning I have discussed with you that carbon and its compounds produce a lot of heat when they undergo combustion. So as the carbon compounds produce a lot of heat on combustion, they are used as a fuel. Thank you so much for watching this video. I hope each and every point is clear to you. Post your doubts in the comment box. Don't forget to subscribe my channel and don't forget to like and share this video with your friends. In my next series, I am going to cover the remaining portion along with important questions from each and every chapter. Thank you so much. Have a nice day.